Hello class, today we're going to be looking at multi-step inequalities day number 2. Okay, so I like this quote up here on the board. It says, don't let idiots ruin your day. So don't let that happen. Don't let idiots ruin your day. Just remember, I'm not an idiot. I'm just your math teacher. Okay, so here we go. Let's kind of review. Okay, so here is a typical standard multi-step inequality. We found out yesterday that we solve inequalities exactly the same way we solved equations. Okay, so there's a couple things that we look for in this problem first in order to do it. Okay, so the first thing we look at is, do we have any minus? Okay, so I do have a subtraction, so I'm going to change the subtraction to addition next to its opposite. The next thing I've asked you to look for is look for the coefficient, okay, the number that's with our letter, and determine whether or not it's positive. Well, in this particular problem, I can't do that yet because I have two coefficients. Okay, so we have to get our letters together first before I can determine anything about that inequality, because you know, if my coefficient ends up positive, I can leave my inequality the same way it is. But if my coefficient becomes negative, that's when this inequality's got to flip at the end of the problem. Okay, so we got to keep that in mind. Okay, so right now all I got to do is get my letters together. So I'm going to move my 9x to be with a 13x. So I start at the inequality and I write 9x plus what it takes in order to move it, negative 9x, plus negative 12. And then over here, I'm going to do the same thing, 13x plus 8 plus negative 9x. And then I combine like terms, okay, just like we did yesterday, because this is a problem that we worked yesterday. We're just kind of reviewing it. So we got the 13x and the 9x. They can go together to make a 4x plus 8 is greater than or equal to. My 9x's go away, and I'm left with negative 12. Now I can make a determination as to whether or not I'm going to flip my inequality. Because this 4 right here, this coefficient, it has all the power. If it's positive, I don't mess with this thing. I leave it alone. If it's negative, then at the end of the problem, I'm going to have to flip it. So in this particular case, since it's positive, we leave it alone. And we just solve the problem just as normal. So I move the 8 over to be with a negative 12. So 4x plus 8 plus negative 8 is greater than or equal to negative 12 plus negative 8. So my 8's go away and we're left with 4x is greater than or equal to, and then negative 12 and negative 8 make negative 20. We divide both sides by 4 and we end up with x is greater than or equal to negative 5. So values that will make this statement right here true are any x value that is greater than or equal to negative 5. Okay, so if we were to check this, okay, is 0, the number I like to use to check a problem with, is it part of the solution set? Is 0 greater than negative 5? Yes, it is. So I could use 0 to check this problem. So if I did, I would do 13 times 0 plus 8. Is that greater than or equal to 9 times 0 plus negative 12? Well, 13 times 0 plus 8 gives me 8. Is that greater than or equal to 9 times 0 plus negative 12? Which is negative 12. And yes, it is. So we know that works. Okay, so that is our basic understanding of how we solve inequalities. So let me give you one to do on your own. Now this one's a little bit different because it's got a little bit more to take care of. Okay, so pause the video and let's see if you can answer this one on your own. Okay, let's see how you did. First thing I see is I do see a minus that I want to take care of. So I'm going to take care of this minus. Okay, now what I've taught you is that if there's anything that can go together on one side, you put it together. Okay, so we come over here. I got a 9 and I got a 7x plus negative 3x. So I like working with my letters first because it is all plus. So I can rearrange it however I need to. So 7x and negative 3x will make 4x plus 9 is greater than. And then on this side, I've got a negative 2x, no x's to go with it, and then the 5 and the 4 can go together, which gives me plus 9. Now the problem looks normal. Now I can solve it. So I need to move my 2x over on this side. Okay, so greater than negative 2x plus 9. Then 4x plus 9 plus 2x. So 4x and 2x make 6x plus 9 is greater than, my 2x's go away, and here I've got, not plus, I've got 9. Okay, so far so good. So now move the 9 over to be with the other 9. So 6x plus 9 plus negative 9 is greater than 9 plus negative 9. So 6x is greater than 0. Okay, we divide both sides by 6, and we get x must be greater than 0 in order for this particular problem to be true. Okay, so I need all x values greater than 0. So I could check it with a 1 or a 2 or a 3 or any of those, but that's how we solve inequalities. That is our normal thing. So what did we do? Well, basically we did this. Step number 1, get your letters together on one side of the inequality. How do I do that? Add the opposite. Step number 2, get your numbers on the other side of the inequality and add the opposite. That's how you do it. Okay? Now there is some pre-work sometimes that we have to do before those, but that's basically what you do. And then the last step is to solve. And how do I do that? I do the opposite. But what you have to remember is that if your coefficient, the number with your letter, is negative, you must flip the inequality at the end of the problem. Okay? So now, what we're going to do for the remainder of this lesson is just kind of work some problems. Because, yesterday you saw all the standards that we had to do. And I showed you those problems that we were going to have to look at. So today, we're going to look at those problems. So we're going to start off with what appears to be a basic problem. Okay, so here it is. Okay, so what do you think we got to do here? Excellent. We do have some pre-work. We got some things that we need to put together. Okay, so here I've got 5x plus 9 is greater than, well, this 2x and this 3x can go together to make, 5x. So now, 5x, something strange is going to happen, plus 6. Now, what have I said to do? Okay, I've told you that, what we have done in the past is you had to actually physically remove this line. 5x plus negative 5x plus 6, 5x plus 9 plus negative 5x. So then my 5x's go away, and I'm left with 9 is greater than 6. Now, I told you now we don't have to do all of that. Okay, you can use one small little shortcut. Okay, and the shortcut that we use is, okay, if I notice that my letters are the same, I can just cross those out and write the resulting line. And yes, you have to write the resulting line. This resulting line is 9 is greater than 6. Now we ask ourselves, is that a true statement? Is 9 greater than 6? Yes, it is. So if it's a true statement, if my letters are eliminated and the resulting line is a true statement, what do we put? We put all real numbers. Simple as that. So we can even have situations like our letters eliminating, even in inequalities, when we have multi-step inequalities. Okay, so what about this one? Well, in this one I do see some minus I need to take care of. So I'm going to take care of some minus first. So I'm going to take care of that right there. Now, I don't like the way this one here is written, so I'm going to rewrite it. Negative 4n plus negative 7 is less than or equal to negative 4n plus negative 8. Because it's plus, I can do that. Now, what do you notice about your letters? Same thing in the last problem. Okay, my negative 4n's, they're going to go away. And we're going to be left with 7, or negative 7, is less than or equal to negative 8. And we ask ourselves, is that a true statement? Is negative 7 less than or equal to negative 8? And no, it's not. So, if our letters are eliminated and it makes a false statement, what kind of an answer do we provide? We provide no solution. Simple as that. That's all we got to do. It's that easy. So we can have that even within the problems that we're doing now with inequalities. Okay? So just kind of keep in mind, these are the reasons why we're doing all this stuff. Don't pay any attention to the stuff up here. I didn't change that date there. Good grief. Okay? So the standards that we looked at yesterday, that I underlined all that stuff, that's a lot of stuff. And so today what I want us to do is actually look at some of the word problems that represent these. Okay, so the first part is just be able to solve it. And that's what we've done. Okay, we know how to solve multi-step inequalities now. Now let's see if we can do all these other things that are necessary for us to do. And the first one deals with word problems. Okay, and these word problems, a lot of times what we're doing in these is we just have to take what's written in all of this stuff here and translate it into a inequality. So let's see if we can do that. It says Susan is going trail biking. She can buy a bike for $300, or she can rent a bike for $40 an hour. In both cases, she must also rent a helmet for $6 an hour. Which inequality shows the number of hours Susan must bike for the cost of buying a bike to be less than renting a bike? Okay, so what's important? Anytime you have a word problem, you got to figure out what's important. Susan's going trail biking. She can buy a bike for $300, and she still will have to rent a helmet. Okay, so that's going to be in both cases. So she can buy it for $300, and then she's got to rent a helmet for $6 an hour. So our variable becomes H, okay, or in this case X, but it could represent hours is what it is. So for that particular one, do you see anything in the answer choices that tells us $300 plus $6 an hour? Okay, well, if you look here in A, it's right there. In C, in B, and D, every one of them, it's got that. 300 plus $6 an hour. Now we're comparing that to renting a bike for $40 an hour plus the $6 an hour for the helmet. Okay, so really every hour we're spending $40 and we're spending $6 for a helmet, which is a total of $46. So in our problems down here, do you see anything that represents that? Well, A only has 40x, C only has 40x, so they don't take into account the helmet. But if you look at B and D, they both have 46x. Okay, so that's what it is. That's what it represents. Now, the last thing we have to do is figure out what kind of inequality are we putting in here. It says, which inequality shows the number of hours Susan must bike for the cost of buying a bike to be less than renting a bike? Well, buying a bike was the 300 one. Okay, so we're looking at these two problems right here. I want the buying a bike to be less than renting a bike. Well, this is buying a bike is greater than renting a bike. This is buying a bike is less than renting a bike. So what's the correct answer then? D, and that's how you have to match it up, just like that. Okay, so that's one type of problem that you're going to have to do. Well, here's another type. Which situation can be represented by the inequality 15x is greater than 12x plus 100? So they give you the inequality, and you've got to match it to a scenario. Okay, so this is one of those where you really have to read and be very careful. Okay, so A, Sally saves $15 each week. Fred has already saved $100 and saves $12 each week. When will Sally have less money saved than Fred? Okay, so we got to look at what's going on in these two things up here. Well, in this first one, Sally saves $15 each week. Well, our X then represents weeks. So here is Sally in the first problem, 15x. Fred has already saved $100, so that's $100, plus $12 a week. So here's $100 plus $12 each week. So this is Fred. Okay, so there's Sally, there's Fred. Okay, now it says, when will Sally have less money saved than Fred? Okay, in this particular one, since this is Sally, we're looking at Sally is greater than Fred. So what do we need? What is this one? This one is less than Fred. So this one is out. So then we go to the next one. Sally saves $12 each week. Oh, well, we just said Sally saved 15, but it could be the same. $12. Fred has already saved $100 plus $15 each week. So it doesn't even match the number, so we know that one's out. Sally saves $15 each week. Okay, that's good, 15x. Fred has already saved $100 and saves $12 each week, so that's good. When will Sally have more money saved than Fred? So here's Sally. When is she going to have more money than Fred? That's the correct answer. Okay, does that kind of make sense? You see how that works? So you have to kind of interpret this based on these words, and that's why the words that we copied down on that very first day were so very important. Okay, now, here's the next one. We got two more to do. Now this one, they're asking you to read the problem, translate it, and solve it all at the same time. Okay, so I'm going to move these answer choices down real quick. Okay, so that we have room to solve our problem. Okay, so here we go. 4 times a number is less than or equal to the sum of a number and 6. What are the possible values of the number? Okay, so it says 4 times a number. Okay, so that number then becomes our variable. And we want 4 times the number, so that means it's going to be 4n or 4x. I guess they're using x in the thing down here, so we're going to say 4x is less than or equal to. So that means is less than or equal to the sum. Well, sum means that I'm going to add. Well, what am I adding? The sum of a number and negative 6. And you put those in the order that they appear when you do that. It says, what are the possible values of the number? Okay, so now what we have to do is just solve this one. So our numbers are already together because we only have one, so that just means I need to get my letters over to this side. So I start at the inequality, x plus negative x plus negative 6, 4x plus negative x. So I put the 4x and the negative x, which we know is negative 1x. 4x and negative 1x give me 3x is less than or equal to. My x's go away and I'm left with negative 6. Now that my x's are together, is my inequality going to flip? No, so I could eliminate any answer that doesn't have that inequality there. So this one's good, this one's bad, this one bad, this one bad. Okay, so if you notice, I've only got one answer that would even be remotely possible. So my answer has to be A. And if I divide both sides by 3, I end up with x is less than or equal to negative 2, which is exactly what we said. Okay, we got one more problem to do, and that's this one right here. Sometimes we got to look at these in terms of a graph. Kai's cell phone plan includes 250 texts per month for $15. Each additional text costs 20 cents. He also pays $45 a month for unlimited talking minutes. He or his mother has given him a phone budget of $62 a month. Which solution can be used to find X, the number of additional texts Kai could send without going over his budget? Now, a lot of times when you look at this stuff, you can kind of look at it and really tell without even writing something down. Now, can you send half of a text? No. Can you send a quarter of a text? No. Can you send a tenth of a text? No. But that's what this one here is saying. Could I send all of those kinds of things? Or can I only send each individual text? I can only send one text. I can only send 2 texts, 3 texts. You can only send a whole text. You can't send any partial text. Well, that's what this line right here represents. 0 to 10. Okay? Well, let's look at the next one. This one says you could do 0 texts or 10 or more. Would that be, could you send all these texts right here in the middle of those? No. Okay, could we just send either 0 or send 10? No. Because what about 1, 2, 3, 4, and 5? Well, D down here says you could send 0 text or 1 text or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. So we're assuming then that you can only have 10 texts, and if we did the math, we could actually show that. Or you could just look at the graph and say, well, I can't send a partial text. So it can't be any of these that have the whole thing covered in. It can only be partials. So the only answer that makes any sense is D. And we did that without even doing any work, just using some common sense. And a lot of times in math, that's what we have to do. Okay, so today I'm not going to give you an assignment because it is on the weekend, and it is a 3-day weekend. So I wish you a really nice weekend, and I'll see you again on Tuesday.